In this video, we're going to talk about adding and subtracting rational expressions. Again, rational expressions are really just fractions. And in our work today, we're going to be working with fractions with a bunch of variables. Okay, so adding and subtracting is a little bit different than multiplying and dividing. In order to add and subtract, we really need to have the denominators that are alike. So we're going to start out with some examples where the denominators are already alike. And then we're going to do a couple examples where we need to get the denominators to be alike. Remember, when you add or subtract fractions, we add or subtract with the numerator only, and we keep the denominator the same. Right? The denominator kind of tells us what type of fraction we're adding and combining. And the numerator tells us how many of that fraction we have. So I have 1/8, and I'm going to subtract 7/8, right? So the eighths is the same. It's kind of like apples to apples, right? So I subtract the numerators, but I leave it the same. That's that common denominator in the bottom. Just like in the last video, when we get to our final answer, we want to reduce if we can. So we'll break apart the numerator and the denominator. Let me do it like this, okay, to see if there's anything that we can cancel 1 for 1. All right, so that's the basic idea of what we're doing. So let's try a few examples. Okay, so this is addition. Notice the denominators are the same. So we're going to go ahead and add and put them together into one fraction. So 3t plus 2 minus 2t. Since they already had a common denominator, we're going to put them over that denominator. All right, then we want to make it as simple as possible. So we're going to combine things in the top. 3t minus 2t is 1t plus 2. And to see if we can reduce, like we did here, we're going to factor the denominator. Two numbers that multiply to be -6 and add to be 1, so I think 3 and 2. And we want a -1, so we're going to want a -3 and a +2. And what do you know? We can cancel 1 for 1. If I cancel everything in the top or everything in the bottom, there's a 1 there, right? Sort of like a placeholder. So my final answer would be 1 over t minus 3. All right, let's try another one. This one is subtraction. We also have a common denominator. So I'm going to write it as one fraction. For subtraction, I like to put the second fraction's numerator in parentheses because I need to distribute this negative that I'm using for my subtraction. So I'm going to distribute the negative. That's going to become 2z minus 3z plus 4. Okay, and that's the same as -z plus 4. All right, we've talked about this in a previous video. I am allowed to reverse the two numbers around a plus. So let me go ahead and do that. I'm going to go this way since I'm out of space. So if I put the 4 in front, plus -z in the back, Adding a negative is the same as subtracting a positive, right? These together are just one negative. So really this is 4 minus z over 4 minus z. Think of this as one unit, right? So I can cancel them out. If I cancel them out, I have ones left in their spot. So my final answer is just 1. Okay, so both of these examples had already a common denominator. So now let's look at some examples where we don't have a common denominator and talk about what to do. All right, so just to get us started, I have an example here that just has numbers because it's good to just review that first. It's the same process. It's easier to look at. Okay, so to get a common denominator, usually I want to try to find a number that both 8 and 12 go into, right? Usually I'm looking for the smallest denominator possible. That might help you out, okay? But as long as it's a common denominator, it's fine if it's not the smallest, but it's not a bad idea to try and shoot for the smallest. Okay, so a number that both 8 and 12 divide into would be 24, right? We're looking for a number bigger, not the GCF here, right? So I want to rewrite these fractions over this new common denominator of 24. To rewrite them, I need to multiply the top and bottom by the same number. So to go from 8 to 24, I had to multiply by 3. So anything I do at the bottom, I also need to do the top. So 3 times 3 is going to give me 9. To go from 12 to 24, I'd have to multiply by 2. Anything I do at the bottom, I need to do the top. So 5 times 2 give me 10. Now I'm in the situation that we had in the last couple examples. I'm going to keep the denominator the same. That tells me what kind of fractions I'm adding up, and the numbers in the top tell me how many. So I have 9 plus 10 is 19 24ths. Okay, and since 19 is prime, I can't break it up. I know I can't reduce this one. All right, so let's use that idea to do one with variables. Okay, so these actually have a common factor of x, which means that I don't have to multiply these and use x cubed. I can use x squared because x squared goes into x squared and x goes into x squared evenly. Again, if you used x cubed, it wouldn't be wrong, but this would be the smallest thing you could use. Okay, so I really am not changing the first fraction because I still have the same denominator I'm using, but I am changing the second fraction. I'm multiplying it by x on the bottom and on the top. So in the top, I'm going to put the x in the front just because that's how we're used to seeing it. Okay, and now that the denominators are the same, I'm going to rewrite it as one fraction. I'm going to distribute that minus x. Okay, I'm going to go ahead and write this in descending powers of x. All right, and normally I would try to factor this up here. I don't think this is factorable, and even if it was, the factor is not going to be x or x squared. It's So I think we're done. Right? There's nothing really that we can do to reduce this. So this is our final answer. All right, so hopefully this is the part that we're adding, right? We're getting that common denominator, and that's going to allow us to combine it into one fraction and get our final answer. I think I have one more for us to try. Oh, two more. All right. Okay, so x and x plus 4, think of the x plus 4 like grouped together, right? These do not have a common factor. I know you can see the x in both, but they aren't, the x is not a factor of this, right? Factor means multiplied. This is added. So since they don't have anything in common, the only choice we have is to multiply them together. And use that as our common denominator. So to rewrite the first fraction, I need to multiply by this x. Anything I do to the bottom, I have to also do to the top. So x times x is going to give me x squared. For the second fraction, I need to multiply the bottom by x plus 4. Again, anything I do to the bottom, I also have to do to the top. So I'm going to have x minus 1 times x plus 4. So this becomes x squared minus x plus 1 times x plus 4. Okay, now don't be tempted to strike things out here. We have to do the subtraction first before we can reduce. So I'll have x squared. I'm going to keep this in parentheses so that I can do the negative last. If I FOIL this, it'll have x squared. On the outside, I'll have plus 4x. On the inside, I'll have plus 1x. So that's 5x altogether. And then plus 4. Now I'm going to distribute my negative. So I'll have minus x squared, but I'll also have minus 5x and minus 4. And the x squareds will subtract to 0. Oops. Okay, and then for this problem, I can't factor the numerator. So I know that I can't really reduce this at all, right? The best thing I could do would be to look for a GCF. But 5 and 4 don't have any common factors. So that's my final answer. All right, let's try one more. For this last one, we're going to need to factor the denominator. That's going to help us find a common denominator. So let's try that. So if I factor, I can't factor in minus 5, but I can factor this as a difference of squares. Okay. Now here's where my common denominator, right? If they share anything, these both have n minus 5. I don't have to have that n minus 5 twice. I really just have to have it once because they share it. So I really want my common denominator, I guess I'm going to go over here, to be n plus 5 times n minus 5. Right? I don't need to multiply all of these together. I did that on the previous example because these two things didn't share any common factors. But this whole denominator and this denominator share a common factor. So if it's in common, I only need to use it once, or at least, that's so hard to put into words, but only the number of the highest number that this is represented. And the highest number in each denominator is once. I hope that makes sense. Okay, so I really don't have to change the first fraction. I can leave that as a 3n over the denominator. But the second fraction, in order to get this denominator, I have to multiply by n plus 5. And again, anything I do in the bottom, I have to do in the top. Okay, I'm going to come over here towards the middle now. So that if I combine that into one fraction, it's going to be 3n minus 6 times n plus 5. So let's distribute our negative 6. Okay, so once we've done that, then we're going to have 3n minus 6n, so that'll be negative 3n minus 30 All right, now this numerator is factorable. There's a GCF here, so it would be worth just checking to see if we can cancel anything and reduce. So if I factor out, I'm going to do a negative 3. That seems like a good choice. I'm going to be left with n plus 10. I was really looking to see if I would get n plus 5 or n minus 5 so that I could cancel, right? But they don't match, so I can't cancel. So I didn't have to factor, but it is good to check. So there are times when your final answer might need to be reduced. The only way to check for that is to factor. Okay, well, I hope this helped give you a little bit of an idea of how to add and subtract fractions like this with variables. I think the most challenging skill in this video is getting that common denominator. So that's going to take some practice. So go see if you can find yourself some problems, go look in the book, try some online, and then send me your questions. All right, well, good luck. I'll see you in the next video.